Hey everybody, Trey here. Welcome back to another video. As you can probably hear in my voice, still recovering from a little bit of a cold, but feeling better now, and that is a good thing because we have some severe weather to talk about. Today we have a level 4 out of 5 moderate risk across the red shaded region here. That's going to include places like southwest and west Kansas into northern Oklahoma. Places like Garden City, Dodge City, Liberal, down almost to the Woodward area of northwest Oklahoma, over toward the I-35 corridor near Wichita, all in that moderate risk for severe weather for today, surrounded by a large level 3 out of 5 enhanced risk and a level 2 out of 5 slight risk in the yellow and orange shading there from the central high plains and Midwest southward into parts of central Oklahoma and the Texas and Oklahoma panhandle. So a widespread area under the gun for severe weather for today, but it is going to focus in the orange and especially the red shaded regions you see there. All hazards going to be on the table for today. The main threat today is going to be significant straight line damaging winds. 45% hatched region in the pink shading there. So the threat for severe straight line wind gusts in excess of 75, 80, 85, even 90 miles an hour tonight going to be a significant concern with this setup. 30% hatched risk for significant damaging winds outside of that as well, including eastern Colorado all the way through much of Kansas, southward into Oklahoma, and even down to the OKC metro. Could see some significant straight line damaging wind gusts for today. Large to very large hail, also a possibility. 30% hatched area there in southern Kansas and in northern Oklahoma, stretching back into the eastern Colorado region is that stippling there. So some significant hailstones, 2 to 3 plus inch diameter hailstones possible for today. The tornado risk is a little bit more uncertain. They do have a broad 2 and 5% region there from across Kansas and northern Oklahoma. A little bit unclear how things are going to evolve at this point, but the main threats today expected to be significant straight line damaging wind gusts and large to very large hail, but a few tornadoes are possible, especially early in the convective life cycle with any more discrete supercells. The threat shifts east into tomorrow. We have an enhanced risk level 3 out of 5 from the Midwest and Great Lakes down into the Mid-South region. So southeast Missouri, northeastward through southern Illinois, much of Indiana, northwest Ohio, southern Michigan under the gun for that greatest severe weather threat for tomorrow, with a large slight risk extending all the way down into the southern plains, including OKC. Tornado risk is at a 5% up there from the Great Lakes southward into the Midwest, with a 2% stretching back into Oklahoma. Damaging winds also going to be maximized in that enhanced risk corridor there, 30%, along with large to very large hail. So all hazards on the table for tomorrow as the threat shifts east. So this video going to focus on today and tomorrow, particularly today with that level 4 out of 5 moderate risk. Significant severe weather is likely this evening across parts of the central and southern plains. Before we get started on today's forecast, I've gotten a lot of questions about yesterday's somewhat surprise tornado event in southwest Nebraska near North Platte. Just an absolutely stunning tornado occurred there. It lasted for about an hour just south of the North Platte area near the town of Wellfleet, and it was one of the most photogenic tornadoes we've seen in quite some time. Really tornadic perfection, if you will. Open land, no houses in sight, it appears, and just a beautifully photogenic, long-lived tornado that people could get close to and get some great shots of. So I wanted to go through just a few things about this tornado. If you're not interested in this and you want the forecast, I've added chapters into the description box below, so you should be able to skim ahead as needed toward the forecast if you need that information right now. But just wanted to address the situation yesterday because it was a pretty stellar tornado that occurred there near the North Platte area. Really not a ton to talk about here. Fairly simple progression and environment with this tornado. We'll start off at the surface. We had a clear surface boundary in place. This is our surface map at 0Z yesterday, so that's going to be 7 p.m. Central Daylight Time yesterday. And you see a clear boundary, what appears to be a clear frontal zone here, out across Nebraska, down into northeast Colorado. You see the wind shift there. Northeasterly winds on the north side of that boundary, southerly winds to the south, with a little bit of a temperature gradient as well. Temperatures in the 90s there to the south of the boundary, 80s to the north. So a clear boundary and a diffuse one at that. Not one of these strong boundaries that has a very strong temperature gradient across it. Those boundaries don't often work for significant tornadic activity because that strong temperature gradient across it tends to allow the boundary to keep moving, or if storms form along it, tends to those storms tend to really just shunt that boundary easily off away from those storms, easily undercutting them. But very diffuse boundary here, very subtle temperature gradient across the boundary, sunshine on both sides of the boundary. We'll talk about that as we look at satellite here in just a second. But overall, boundary was in place out across the area. Here is North Platte right here. So North Platte just on the north side of that boundary by the time the tornado occurred around 0Z, around 7 p.m. Central there. So this storm occurred just very near or just on the north side of the boundary, but overall, the environment on both sides of the boundary very similar, not a strong temperature gradient across it. So even though the storm may have been just on the north side of the boundary, it was clearly surface-based and was able to produce a significant tornado. So boundary in place there, appears to be somewhat of a weak frontal zone there. Let's take a look at the vorticity along that boundary. Very vorticity-rich boundary. So this is the 3-cape and vorticity plot from our SPC mesoanalysis page going back to yesterday. This is at 21Z. So you see the blue contours here. Those are your vorticity contours. The red contours are your 3-cape, 0 to 3 kilometer instability there. We've talked about this before. When you have vorticity or spin along the boundary, that can get easily stretched into the vertical as updrafts go up along that boundary. It can easily tilt and stretch that spin into the vertical with strong low-level instability to aid in tornado genesis, either of the non-supercell variety or of the supercell variety. And you see here this boundary was very vorticity-rich, so that frontal zone draped right across here. You see those blue contours right along that boundary. So this boundary was very vorticity-rich. We go into the evening yesterday, 22-23, 0Z. So our storms, you can see, start to fire up right there, right in a little bit of a bullseye there, an overlap of adequate 0 to 3 kilometer cape with strong surface vorticity there. So this was a vorticity-rich boundary, and we had strong low-level instability to help tilt and stretch that vorticity into the vertical underneath these updrafts. So right away, this does lend some confidence that this may have been a little bit more of a hybrid type tornado. And if we go and take a look at some of the images here, let me go and show you this image from Jeff Frame. He was near this tornado for its entire life cycle. This was in the early portions of the life cycle here. This was clearly has that landspout look, flat base here, a little bit of a nipple funnel with that nice faint dust tube underneath it. So it does appear that this tornado may actually have started as a landspout where you had an updraft go up along the boundary, right in there, started to really amplify, tilt, and stretch that vorticity into the vertical with that strong low-level instability, and it may have started as a landspout. Then the storm likely developed a mesocyclone as it moved, as kind of propagated near the boundary to the south, near Wellfleet. The storm may have developed a mesocyclone, and the tornado may have become supercellular in nature. Very similar to how the Gerald, Texas tornado definitely began. We've talked about that in our past case study on Gerald, but began as what appears to be more of a landspout hybrid type tornado near the outflow boundary, cold front intersection there. Tilted that vorticity into the vertical updraft and kind of moved over that, tilted and stretched that vorticity into the vertical, and then became supercellular in nature as it propagated southwestward along the boundary to aid in the transition to more of a supercell tornado. So very similar evolution here, where you have a sort of a landspout or hybrid type tornado first. These updraft gains supercellular characteristics, gains updraft rotation or mesocyclone, and the tornado becomes purely supercellular after that. So very, very interesting evolution here, it appears. And it's pretty clear what this was due to. Boundary in place, strong vorticity along that boundary, tilted and stretched into the vertical as updrafts went up along the boundary, and you got that kind of initial tornadic activity as somewhat of a hybrid or landspout, and then the storm became supercellular in nature and eventually went into full supercell tornado mode. So we've seen this before, and it was certainly an interesting evolution yesterday. Background pattern, certainly, if you were to tell me that there was a significant tornado from this kind of a pattern, I'd kind of think you were a little bit wonky, especially a kind of widespread tornado event yesterday. We had several tornadoes up there in Minnesota ahead of an MCV, and then down here in Nebraska. Definitely doesn't look at the surface like your typical 500 millibar pattern for a significant tornado event or outbreak of any kind, but it did the job. So if we go forward in time here, you see not much going on across the plains, just some slight ridging there across the southwestern quadrant of the country. Not a ton of change in the overall 500 millibar pattern with time here. Yesterday, just a little bit of about 10 to 20 knots of flow here out across that region, so very minimal forcing. Really, we were relying on that boundary and strong heating along that boundary. Temperatures got up into the 90s, as you see there, near and south of the boundary, helping to initiate some of those updrafts along the boundary. With minimal background forcing for ascent, we were really relying on convergence along the boundary and strong surface heating. So if we go to our satellite here, you can see the evolution, very interesting evolution here. You can kind of see where that boundary is just a little bit, right in this vicinity here. And you see initially some cumulus start developing well to the south of the boundary, it appears. You see these little cumulus down in here. Those were the seedlings of our storms that became the Wellfleet supercell. So those moved up to the north along the boundary, started to get a little bit more robust. And then interestingly enough, as this high cloud cover came into the region and overspread these storms, the storm started to explode. You see in a few minutes there, the tops explode through that high cloud cover there. Could be a little bit of a weak shortwave moving through the flow. Tough to tell from our background mesoanalysis here. Little bit of a ripple maybe there in the flow moving through here. Not much to speak of, though. Very difficult to see anything really robust, but overall could be just a little bit of a disturbance, a little bit of a shortwave moving through. A little bit of extra forcing to help these cumulus become robust thunderstorms, and they certainly did that very quickly. Those storms expand. You see the overshooting tops there, just a pretty classic satellite image right along that boundary. And then we were off to the races there. Storms maintained a very discrete nature as well, with minimal forcing, not all that surprising there near that boundary. Very subtle boundary as well. When you have a strong temperature gradient across your boundary, that can lead to quick upscale growth because you have just such strong convergence along the boundary. Lots of updrafts go up. Not the case with this boundary. Storms maintained a very discrete nature for quite a while. And finally, to wrap up our discussion of this tornado event in Nebraska, this is a proximity sounding from the Wellfleet tornado yesterday. 0Z sounding taken near the storm in question. And this is a pretty classic sounding for these kind of quote-unquote surprise significant photogenic tornado events. Very strong instability also in the deep layer, also likely a culprit. Yesterday you can see very strong instability there, fat cape throughout the entire profile with mixed layer cape exceeding 4,000 joules per kilogram. So very strong instability on the deep layer led to very robust updrafts. 90 over 67 at the surface. Again, a little bit high up the temperature dew point spreads there, but up in this part of Nebraska, a little bit higher terrain doesn't matter all that much, especially if we were just on the cool side of the boundary. May have brought those spreads down ever so slightly. Also, a little bit of shading from that high cloud cover could have been a culprit as well, bringing those spreads down just a little bit, but this certainly was a tall photogenic tornado, so spreads were definitely a little bit on the high side, but still adequate. So strong instability, strong low-level instability as well. Given that storms were a little bit high-based, that's why we're not seeing those crazy 0 to 3 kilometer cape values. This is basically the extent of your 3 cape there. If bases were a little bit lower, we'd see a ton of 3 cape. It's still more than adequate low-level instability to stretch that vorticity into the vertical. Strong deep layer instability for robust, extremely robust updrafts. Your hodograph, not a ton that you'd think would signal significant tornadic activity. Your 0 to 5 half kilometer level there, very short. 0 to 1 kilometer levels, very, very short segment there. But sometimes it just doesn't matter when you have strong vorticity along the boundary with strong low-level and deep layer instability. We've seen this time and time again. Cases like Hawley, Texas, May 2nd last year, a great example of that, where you just had strong instability, limited low-level shear, but a boundary that was in play. Vorticity tilted and stretched into the vertical along that boundary. You did have strong venting, though. You see the hodograph is fairly lengthy there, extending off to into the bottom right quadrant helping to vent any precipitation well off away from the area of interest of this storm. So strong instability, strong venting, that's a combo that can really induce these photogenic significant tornadoes. And we certainly had that in spades here. Even though we had northeasterly surface winds just north of the boundary, doesn't really matter up here. This tends to be something that works out up here. The Hyannis, Nebraska tornado from this past year was a great example from that. A couple months ago in late April 27th, I believe. That was another case where you had, I believe, northeasterly surface winds. So sometimes it just doesn't matter. If you have a boundary modified on both sides of the boundary, we saw there with our satellite imagery, both sides of the boundary baking through the day. So you had a nice diffuse boundary, very similar thermodynamic characteristics on both sides of the boundary, not a strong temperature gradient across it given that sunshine on both sides. And that was a key with this event. Even though we had very limited low-level instability, low-level helicity, that boundary was critical here. So all in all, fairly simple case here in hindsight. Definitely going to start remembering this type of an environment here, especially when a boundary is in play for these kind of photogenic tornado events. So overall, very impressive event yesterday, and definitely a tornado that's going to be remembered for quite some time. All right, let's get into the forecast for today and tomorrow. Start off with today again, moderate risk out for southwest Kansas into northwest Oklahoma. Let's take a look at what's going on right now. I'm recording this just after 10 a.m. Central Daylight Time, and this is what we have going on right now. Leftover remnants from an overnight convective complex moving through southeast Kansas into eastern Oklahoma this morning, with another round of storms moving quickly southward across parts of northwest Kansas. So a lot of convection continues this morning, lends a little bit of uncertainty into the forecast. You can see the outflow from this convection racing southward here. And so this is muddying the forecast up a little bit. Some of the earlier model runs from the last couple days did not have this much convection in the morning. So just going to have to wait and see how this plays out. If this outflow keeps surging southward, it's going to be a little bit of a problem as far as kind of ruining the environment for later on in the event. But overall, let's take a look here at our background pattern. So this is at 15Z, again, recording this just after 10 a.m. Central Daylight Time. Not a very active jet stream per se, but we do have a few little disturbances moving through this flow. A little bit of a trough across the northern U.S. into Canada, one here along the southeast coast, going to move off to the east today. Then we have this one back here, a little bit of a very low amplitude trough here across the Intermountain West, from Colorado, Wyoming southward into the desert southwest. So this little bit of troughing is going to move off to the east today and help us with the large-scale forcing for ascent for this activity. See a few little ripples here as well, perhaps allowing the ongoing convection to continue. Our main ripple kind of back here out across the western U.S. going to move through as well, going into the afternoon and evening today, providing a little bit of impetus for storm development, at least on the large scale. 300 millibars, you see a little bit more definition to that trough out west in the height contours here. Slight bit of defluence in the exit region of that trough there from Wyoming. You see those winds out of the southwest, much more westerly flow here across the southern plains, even northwesterly flow over top the ridge that we were talking about earlier for yesterday's event, kind of sticking around a little bit. Going to get suppressed because of this little trough moving in, but certainly some defluence overspreading the plains as we speak, and should continue to do so through the afternoon to allow for storm initiation during the afternoon hours, at least additional storm initiation during the afternoon hours. At the surface, we have a surface low here down across the Texas Panhandle into eastern New Mexico vicinity. Again, not a ton of flow aloft, not a ton, very high amplitude pattern aloft, so we should see this low kind of stick around a little bit as we get this continued westerly flow across the Rockies. Perhaps could see a little bit of this low kind of develop off to the north a little bit into eastern Colorado, but overall, going to see some type of surface low here in that kind of southern high plains vicinity, helping to focus the severe weather threat for today. Moisture these winds have been out of the south for quite a while, should help feed that moisture up into the surface low. Should have ample moisture here across the region for our severe weather threat for today. Here is our Current surface observation map. You see where that surface low is there across the Panhandles vicinity, Oklahoma and Texas Panhandles there. Perhaps just south of Elkhart, north of Dumas there in Texas is our surface low. You see ample moisture along east and to the south of that surface low. Dew points in the 70s across Oklahoma, upper 60s to 70s there from the Red River northward, and as well as southward there into Texas. Dew points well into the upper 60s and some 70s there as well. So very moist air mass here, going to continue to spread off to the northward time as that low perhaps meanders off to the north a little bit, somewhere in southwest Kansas. There we should get this moisture to nicely feed up in a tongue there up into the surface low, providing the juice needed for severe weather later on today. So again, surface low here, warm front, if I had to guess, would be somewhere in this vicinity here at the moment. A little bit difficult to tell as we've had that thunderstorm activity ongoing, but overall, warm front looks to be right in there. Cold front likely back in here as well. See the moisture gradient in there. So these should kind of swing off to the northeast ever so slightly today, and ahead of this boundary, ahead of the cold front, south of the warm front, should be our favorite area for storm initiation. Perhaps by afternoon looking something like this. So the favorite area for storm initiation perhaps could be post-frontal there in eastern Colorado, and then we should get some development there later on, filling in along the frontal zone here near the warm front, moving southward and creating kind of a complex later on, inducing that significant damaging wind threat. All right, now for some observed soundings from this morning. This is the Dodge City 12Z observed sounding. A very impressive sounding here, not overturned by convection from yesterday. So a fairly pristine environment for early in the morning, fairly loaded gun type profile. Lots of elevated instability here above this capping inversion near 700 millibars. You see most unstable cape there, 2,800 joules per kilogram. That's all this instability here up above that capping inversion. So very unstable atmosphere already in place out across the southwest Kansas corridor. Should lead to pretty explosive thunderstorm development later on in the afternoon and early evening. As this cap erodes, we get that trough to come in. Strong surface heating across the region, as we see here from our satellite imagery. You see that boundary? Again, that's going to lead to some questions here with the overall environment, but overall, fairly patchy clearing here across the region should allow those temperatures to soar into perhaps the 90s later on today, allowing for pretty robust instability to be in place as that capping inversion erodes later on. Very steep lapse rates aloft as well, 9 degrees Celsius per kilometer lapse rates there in and around that 500 millibar layer. So very steep lapse rates, likely an elevated mixed layer of sorts, helping to bolster that instability and will likely lead to some very large hail later on today. Large instability around the freezing level should allow for some pretty robust updrafts with large hail and large to very large hail potential today. Kinematically here, not a ton to talk about right now. We are seeing very strong low-level shear. That is going to wane through the day today a little bit, but with a little bit of that low-level jet, assuming that this low-level cyclone sticks around, here's our 850 millibar low. We assume that sticks around here across western Kansas, and we get this plume of 30 to 40 knots of low-level flow to stick around. Then we should have some strong low-level shear for today to pose a risk for some tornadic activity. Again, that is in question based on storm mode and the overall evolution of the convection today. But overall, if we get any more discrete supercells, a few tornadoes are certainly possible. And with the line, the complex as it moves off to the south and southeast tonight, could see a few spin-up tornadoes in that line as well. So that's Dodge City. Norman as well, very much the same, not quite as cool at the surface, but still very steep lapse rates aloft, very strong instability aloft as well, going to lead to some pretty robust convection later on in the afternoon. All right, here is some model data for this morning. This is the 12Z NAM. Starting at 500 millibars, you see that trough there across the west, going to continue to move off to the east today, providing ample forcing for ascent here. Again, it's not a very high amplitude feature by any means, but you see that ejecting into the southern high plains by 21Z or so, should initiate another round of storms here going into the afternoon. And again, just going to have to monitor these boundaries, this outflow boundary, surging south pretty fast here. If that can stall, could be a focus for severe weather later on along that boundary as well. Where that sets up, if it will stall, definitely remains to be in question. We still have some convection on the north side of the boundary, So we'll have to see if it stalls. If it does, then we certainly could see a focus for severe weather along that outflow boundary, but that just is kind of in question at this point based on how fast it continues to move this morning here in the late morning hours today. But overall, forcing for ascent, again, not going to be a problem for today. Plenty of forcing here from this incoming trough that should lead to storm initiation in earnest here by the afternoon. Down at the surface here, you see that fairly weak low-level cyclone here, but definitely present low-level cyclone there across the Panhandles region. Definitely sticks around there today. Kind of just sits there in the Panhandles region this afternoon. Your warm frontal zone, you can clearly see it by the outline of the temperatures there. Cooler temperatures north, warmer to the south. Cold front / dry line down to the south as well. So definitely a little bit of a shift south compared to what we've seen for the last couple of model runs. Earlier model runs had it kind of up by I-70 in northern Kansas. The NAM definitely showing more of a southern Kansas to northern Oklahoma scenario. You see a little bit more clearly those boundaries in play for today, at least on the NAM. Low kind of right in there, dry line right in there. If we go to our moisture here as well, you can really see those boundaries in full. So we go forward in time, you see a little bit of that where that warm front is, tongue of moisture right along that warm frontal zone there in southern Kansas. If a storm can manage to go along that warm front during the day out ahead of the convection here that is expected to become the complex later on today, we could have an interesting situation unfolding. Again, this is all dependent on where these boundaries set up, where the frontal boundary set up. If we get continued convection here, it's going to negate the severe weather threat somewhat, but overall, the NAM has an interesting solution here. If a storm can go, it is a little bit more of a narrow, kind of high moisture area along that warm front, but overall, definitely something to watch out for if we do get discrete development ahead of the impending complex. So again, during the afternoon, we should get secondary development in the post-frontal regime here in eastern Colorado, perhaps into western Kansas, north of the surface low and warm front, shifting off to the south. And again, very, very, very conditional threat for any isolated supercells near the composite warm front / outflow. Outflow reinforced front might be a good term for it there. Then you see by evening, you see the dew points getting eaten out there. That is the complex moving through. Impinging upon this higher moisture would be, at that point, would be a threat for some significant straight line damaging wind gusts and maybe a few spin up tornadoes along the line as it kind of eats into the air mass there going into the evening hours today. Let's take a sounding here. Take one right along that frontal zone, and then we'll take one there at 21Z and then 0Z here in kind of west central Oklahoma. Maybe northwest Oklahoma might be better. So here you are along that warm front. Plenty of strong instability there, over 4,000 joules per kilogram mixed layer CAPE near that warm front, 81 over 71. We do see strong low-level shear here, strongly curved low-level hodographs, effective storm relative felicity nearing 400 meters squared per second squared. So again, very big if, but if a storm can fire near that warm front, we could see all hazards come to fruition there. But more than likely, it's going to be a complex of storms here. Going into the afternoon and evening, you see strong instability maintains itself. Definitely a well-mixed boundary layer here across much of the region, even with dew points in the upper 60s to 70s. Those temps getting up into the 90s here, and that should foster more outflow production with these storms and perhaps quicker congealing of the storms into a line that moves to the south during the evening hours. Tonight we'll go to 3Z here, moving through western Oklahoma. We'll see maybe one up in here across northern Oklahoma just to get a canvas there of the environment. And strong instability, strong low-level shear persists through the evening. So, any more discrete supercells would pose the greatest risk for tornadoes. But again, I think it's going to be a lot of storms developing near that frontal zone. Something to note as well, that if this warm front is going to be our focus here, warm front / outflow is going to be our focus for severe weather, our shear vectors here are very much parallel to that boundary. So that could lead to a lot of storms developing near that boundary and then shifting southeast with the strong outflow production likely. That would lead to a very quick transition to more of an MCS there across the region. So definitely a complex setup for today, but certainly I think that the idea is that a complex of storms is going to develop at some point moving through southern Kansas into northern Oklahoma, with the threat for significant straight-line damaging wind gusts and maybe the potential for a tornado or two along that line. If any more discrete supercells fire up along the warm frontal zone / outflow ahead of the complex and can maintain a more discrete nature, then we could see more of a heightened tornado risk there, as well as a large to very large hail risk, especially early on in the convective life cycle. So let's take a look at a few cams now to take a look at how things might evolve through the day. This is the 12Z HER. So you see a lot of that convection sticks around to the north of that southward sagging outflow. That makes me think that outflow is going to keep sagging quite a bit south, and that could have some pretty significant implications on where the greatest severe weather threat sets up later on and what types of hazards we might see. If we go back to our surface obs here, you see temperatures to the north of that boundary pretty cool in the 60s there. 80s here already to the south, so definitely a temperature gradient across that boundary could lead to some concerns, could be a negative for significant tornadic supercells later on. But again, just going to have to watch how that plays out. You see post-frontal activity developing there across eastern Colorado through the afternoon. We get this complex to kind of strengthen through the day across eastern Kansas on this run of the HER. And then additional development along near that warm front / outflow through the evening, quickly transitioning to more of a damaging wind risk. You see some isolated development here in the eastern Texas panhandle on this run of the HER. Interestingly enough, temperature dew point spreads should be pretty high down there, and that could lead to more of an outflow type situation. High base storms producing outflow. Limited low-level shear could lead to large hail as well. You see 95 over 62 there. Very high temperature dew point spreads there on the Texas Panhandle. Here's the WRF ARW. Has that complex continuing through the afternoon, strengthening a little bit as it gets into eastern Kansas, and then ample development there later on, congealing into more of a clustered mode there out across Kansas and Oklahoma. So kind of a messy situation there on the ARW model, very similar to what the HER was showing. NSSL WRF model here, and much of the same. That complex continues, widespread development there through the afternoon. Maybe a couple more isolated supercells there post-frontally in the panhandles into southeast Colorado, but overall, main threat should come from this complex here moving through Kansas and Oklahoma with significant straight-line winds. All right, very quickly on tomorrow's setup, we see that the trough moves off to the east at 500 millibars, gains a little bit of amplitude there going into tomorrow morning, and then it moves off very quickly into the mid-south of the Great Lakes region by 21Z, strong flow across Michigan down into Illinois and Indiana. That's going to be your main corridor for severe weather. A little bit of trailing flow here back to the south out of the due west there across the southern plains, where the southern terminus of the severe weather threat is expected to be tomorrow. But greatest threat going to be where the strongest winds aloft are tomorrow. We should have enough forcing for ascent with this 500 millibar trough moving through. Cold front will shift off to the east. That low will continue to develop through the evening hours tonight and give us a nice cold front moving off to the east. You see, as we go through with time, we get a little bit of a low to develop there across the mid-south, move off to the north, up into Illinois by tomorrow morning at 15Z, 10 a.m. Central. Surface low there by 21Z, 4 p.m. Central right there in southwest Michigan. Cold front down to the south, somewhere in this vicinity here, stretching down into the southern plains. A little bit difficult, just kind of eyeballing it there. Warm front off to the north, so greatest severe weather threat for tomorrow. Strongest flow aloft, surface low there, up from Michigan southward into Indiana, and perhaps even Illinois, depending on where that cold front is. Less influence there down to the south across the southern plains, so probably going to be weaker shear down there as well. Weaker flow aloft away from the strongest low-level flow. So probably mostly a large hail and damaging wind risk farther to the south across Oklahoma, up there to the north across Michigan into Illinois and Indiana. Greatest threat for severe weather going to be ahead of that surface low. Here's our moisture fields. So going to tomorrow, 70s dew points out ahead of that surface low. You see kind of where that low is, right in there, southwest Michigan. Boundary sagging down to the south. Rich moisture ahead of that boundary. Take a quick sounding here, southern Michigan tomorrow, and then one down to the south. Kind of compare the two there in eastern Oklahoma. Definitely decent instability there, 2,600 joules per kilogram mixed layer CAPE. A little bit saturated there in the low levels, which is interesting. Could lead to more, to quicker upscale growth. but overall strong low-level shear there. Mostly speed shear here, not a ton of veering of the winds with height, but still strongly strengthening winds, 10 knots there at the surface to about 60 knots, just above 850 millibars. So very strong speed shear there in the low levels. Can still get the job done as far as tornadoes go, 330 meters squared per second squared effective storm relative helicity. Could foster that all hazards risk there. With any more discrete supercells, tornado risk would be maximized as well. Just a quick look at some of the cams for tomorrow. So we go through the day today. Complex moves off to the east into the mid-south overnight. And then you see there by tomorrow, early tomorrow, 18 to 19Z, robust storms, including some supercells there from Indiana into Michigan ahead of the surface low. Then some more kind of lower end storms down to the south where the shear is weaker. Large hail damaging winds, the greatest threat there. Tornado risk going to maximize up in here, Michigan into Indiana. All right, that's going to do it here for this video for today. Again, moderate risk here for severe weather across the central and southern plains today, much of Kansas and northern Oklahoma. Garden City, Dodge City, Liberal, Wichita in that red shaded region there, that's our moderate risk. Greatest threat for severe weather is there, surrounded by large enhanced risk. Eastern Colorado through Kansas, northern Oklahoma. All hazards on the table, but again, the greatest threat today is going to be significant damaging winds as storms congeal into a complex later on this evening. That looks to be the greatest threat from this, the most likely threat. Tornado risk, again, is a little bit in question given the storm mode concerns, given the boundary that's surging southward through the region, but overall, could see a few tornadoes, especially with any more discrete activity, 2 and 5% regions there across much of Kansas, down surrounding that as well. Greatest threat there in the 5% risk there in Kansas, northern Oklahoma. Large to very large hail threat as well for today. For tomorrow, enhanced risk level 3 out of 5 from Michigan southward through Missouri. Greatest threat appears to be ahead of that surface low there from Michigan into Indiana. Farther southwest across Oklahoma, weaker deep layer shear, more of a large hail and damaging wind risk there. So, active stretch on the table for these next few days, and then things should shift into the northern plains here. Beyond that, places like Montana, the Dakotas, Minnesota, looks to be under the gun after this period. After these next couple of days, we should be back in the northern plains with our focus for severe weather. So that's going to do it for this video. Thanks for watching, and we'll see you in the next one. Thank you for watching this forecast discussion. I hope you found it helpful. If you'd like to access more free content, head over to stormchasercoaching.com and click on the free button in the menu. There are ebooks, podcast episodes, and even a free community that you can join to connect with weather enthusiasts and storm chasers just like you. The link is in the description box below. Thanks again for watching.